In this video, I'm going to show you some tricks for finding the mixed partial derivatives of functions. Given f equals x2 y to the 3 plus z to the 5 plus arc sine of x radical z, find the partial derivative of f with respect to x, then z and y. So we want to find the partial derivative of this given function first with respect to x. Then from that answer we have to find the partial derivative with respect to z and then with respect to y. And as you can see, this is not easy function, especially this part, arc sine of x radical z. Suppose you want to find the derivative of this with respect to x. Then from that answer you want to find the derivative with respect to z, and at the end you want to find the derivative of that with respect to y. Here we have it. We can use a trick. Remember the Clairaut's theorem. What is Clairaut's theorem? Based on the Clairaut's theorem, we know that for most of the functions, the order of differentiation doesn't matter. What it means? Here we want to find f, derivative of f with respect to x, then with respect to z, and then with respect to y. We can change this order. Instead of finding the derivative with respect to x, then with respect to z, and at the end with respect to y, we can change the order. Instead of that, we can say, let's find the derivative with respect to y first. Maybe you think why it's better to take the derivative with respect to y first. Why it's better to move it to the first? Because, attention, if, especially for this part, we take the derivative of this with respect to y, because in this part of the function, in this term, we don't have any y, so it's a constant. And what is the derivative of a constant? 0. So the derivative of this would be 0, and so only you have this term to take derivative. And it makes finding the next derivatives easier. So this is the technique that we use here. But attention, we can change the order only when the partial derivatives are continuous, which almost for all the functions, the partial derivatives are continuous except very special functions. So we are fine to use this conclusion. So the first thing is that we say f of x, z, y, partial derivative of f with respect to x, then z, then y is the same as partial derivative of f with respect to y, then x, and finally at the end z, or y, then z, then x. It's important to take the derivative of f with respect to y first. So let us start. What is the derivative of this function with respect to y? The derivative of this with respect to y is 3 x to the 2, y to the 2, z to the 5. The derivative of y to the 3 is 3y to the 2, and x2 and z5 are just constant. And the derivative of arc sine of x radical z with respect to y is only 0, because it's a constant and we want to take derivative with respect to variable y, but in this term we don't have any y, so its derivative is only 0. Now from this answer we have to take derivative with respect to x. The derivative of this with respect to x is 6x y to z to the 5, and finally from this answer we have to take derivative with respect to z, which would be 30 x y to z 4. The derivative of z to the 5 is 5z to the 4, 5 multiplied by 6, and this is the final answer for this question. So the thing that we learn from this question is that when you want to find a mixed partial derivative, sometimes it's better to change the order of differentiation. It can simplify your calculations a lot. Now look at this. Function h is given a square root of 4 plus x2 plus z2 plus a square root of 9 plus xy to the 3, and we want to find the third basically order partial derivative of h with respect to x, then y, and then z. So we want to find this mixed partial derivative. First, we want to find the derivative of h with respect to x. And in both of these terms that here we have variable x. But if you pay attention, in this term we don't have any y. So for this part, it's a good idea to take derivative with respect to y first, then take other derivatives. But for the middle term, we have y. So for this term, it's a good idea to take derivative of this term with respect to z. Yes, because it doesn't have any z, so its derivative would be 0. So in this example, what we are doing is that we name this u and we name this v. So our function h is basically sum of two other functions, u and v. H equals u plus v, because u is this and v is this. For the u, we are going to find derivative with respect to y first. Why it's better idea to take derivative of the u with respect to y? Because in u we don't have any y, so derivative of u with respect to y is 0. Then from this answer we have to take derivative with respect to x and z. Because derivative of u with respect to y is 0, so of course derivative of u with respect to y then x, for example, is also 0. And finally derivative of u with respect to y then x, and finally at the end z, derivative of this, because it's 0, with respect to z is also 0. So derivative of u with respect to y then x then z is 0. And attention, this is the same as this, because we know that the order of differentiation is not important. Now for v, we use a different order. For v, we are not going to take derivative with respect to y, because v has y. So for v, we start with taking derivative with respect to z first. But v has no z, variable z, so derivative of v with respect to z is 0. Then from that answer we take derivative, for example, with respect to x, it's also 0, and at the end derivative of v with respect to z then x, and then partial derivative with respect to y is also 0. From this we can understand that for h we wanted to find derivative of h with respect to x, then y, then z. This is the same as finding derivative of u with respect to x, then y, then z, and finding derivative of v with respect to x, then y, then z. But we know that this is the same as this, because the order doesn't matter. This is 0. This is also equal to this, and this is 0. 0 plus 0 is 0. So this means that the partial derivative of h with the third order partial derivative of h with respect to x, then y, then z is 0. So the answer is 0. And as you can see, basically we took almost no derivative in this question. We could find the partial derivative just by a trick. I hope you liked this video. Please subscribe in my channel, and see you in the next videos.